Have you ever looked up at the night sky and felt a little lonely? It's a big, dark, empty-looking space out there. But what if it isn't so empty? What if, just next door in cosmic terms, there was another blue marble, another world, almost identical to ours, spinning around its own star? Imagine waking up and knowing that another Earth, a planetary twin, was out there. This isn't just science fiction anymore. NASA scientists and astronomers all over the globe are on the hunt. They are looking for a world that could be our cosmic sibling, a place that might just have the right ingredients for life. It's one of the biggest questions humanity has ever asked. The idea of a twin Earth has captured our imagination for centuries. But now, for the first time in human history, we have the tools to actually look for it. Every day, new data streams down from our telescopes in space. We are searching for a planet that has liquid water, a comfortable temperature, a protective atmosphere, a place that feels like home, even if it's trillions of miles away. For most of human history, we only knew about the planets in our own solar system. That was our entire neighborhood. Mercury, Venus, Mars, the gas giants. We had no idea if they had planets of their own. We called them fixed stars because they seemed unchanging. But in 1995, everything changed. Astronomers confirmed the discovery of the first planet orbiting a sun-like star outside our solar system. We call these planets exoplanets. And since then, the floodgates have opened. These exoplanets are a wild and diverse bunch: hot Jupiters, giant gas planets orbiting incredibly close to their stars, super-Earths, rocky planets larger than our own, rogue planets, worlds wandering alone through interstellar space. We now believe that, on average, there is at least one planet for every star in our galaxy. There are hundreds of billions of stars in the Milky Way alone. That means there are likely hundreds of billions of planets right here in our own cosmic backyard. And our galaxy is just one of hundreds of billions of galaxies in the observable universe. So if there are so many planets out there, the odds suggest that some of them must be like Earth, right? That's the logical next step. So, how do we find these planets? They are incredibly far away and incredibly faint. Trying to see an exoplanet directly is like trying to spot a firefly next to a giant searchlight, so astronomers had to get clever. They developed indirect methods to detect these hidden worlds. One of the most successful methods is called the transit method. We stare at a star and wait for a tiny dip in its brightness. That dip could be a planet passing in front of it, blocking a little bit of its light. The amount the starlight dims tells us how big the planet is. The time it takes for the planet to pass in front of the star again tells us how long its year is. From that, we can calculate its distance from the star and figure out if it's in the habitable zone. It's a painstaking process. Our telescopes have to stare at thousands of stars at once for years on end just to catch these fleeting moments. Another powerful technique is the radial velocity method, or the wobble method. A star and its planets all orbit a common center of mass. Even a small planet exerts a tiny gravitational tug on its massive star, causing the star to wobble. We detect that wobble in the star's light. Blue shifts when it moves toward us, red shifts when it moves away. When we combine the wobble method with the transit method, we get a powerful 1-2 punch. Transit gives us size, wobble gives mass, together we compute density and reveal if the planet is rocky like Earth. It's through these clever detective tricks that we start to build a real profile of these distant worlds. When we talk about planet hunting, one name stands above the rest: the Kepler Space Telescope. Its mission was simple but ambitious: to stare at a single patch of sky in Cygnus for years. It monitored the brightness of over 150,000 stars, waiting patiently for those telltale dips. Kepler was designed to answer a fundamental question: how common are Earth-like planets in our galaxy? It discovered thousands of confirmed exoplanets and thousands more candidates. It showed us that small rocky planets are incredibly common. Its data suggests there could be tens of billions of potentially habitable Earth-sized planets in the Milky Way alone. One famous discovery is TRAPPIST-1, a system about 40 light-years away. It has not one, not two, but 7 rocky, Earth-sized planets orbiting a cool star. Imagine looking up from one world and seeing 6 other planets, some as large as our moon. Kepler's mission ended in 2018, but its legacy lives on, an archive of data that will be studied for decades. It passed the baton to the next generation: TESS, Webb, and future telescopes. The hunt for Earth 2.0 isn't a search for a needle in a haystack, it's a search for a specific needle in a giant stack of needles. With statistics on our side, we can pick the best candidates for follow-up and characterization. First came TESS, launched in 2018. expanding Kepler's method to nearly the whole sky. Its goal, find the closest, brightest transiting exoplanets, the golden ticket worlds. Enter the James Webb Space Telescope, launched December 2021, the most powerful space observatory. Webb sees in infrared, peering through dust and probing exoplanet atmospheres. TESS finds the planet. Webb characterizes it. Together they are a dream team. During transit, a sliver of starlight filters through the planet's atmosphere. Molecules leave fingerprints. Water vapor, methane, oxygen. Webb can detect those chemical fingerprints, potential biosignatures. Thanks to TESS and Webb, we're no longer just counting planets, we're beginning to read their stories. It's an incredible scientific feat and an exciting time for the search for Earth's twin. On Earth, oxygen plus methane together signal biology. But caution is required. Not definitive proof, just the strongest clue. We can hunt for biosignatures. Finding that mix elsewhere would be monumental. Let's imagine that it happens. An announcement comes from NASA. The James Webb Space Telescope has analyzed the atmosphere of an Earth-sized planet in the habitable zone of a nearby star. Oxygen, methane, and water vapor. The world would stop. The news would be on every screen, in every language. The discovery of a true Earth twin, a world with a potential biosphere, would fundamentally change humanity's perspective. Scientifically, it would be a goldmine, a second data point for life in the universe. For all of our history, we've only had one example, life on Earth. A twin Earth would let us test our theories about how life begins. It could be a moment of unification, a realization that we are all Earthlings. It would launch a new era of cooperation and astrobiology. Should we try to contact them? The debate would rage for generations. In the long term, a nearby Earth 2.0 would become a destination, a target for future generations. It would inspire children and drive innovation, a new world shining as a beacon of hope. When we imagine life on another Earth, our minds often jump to little green men, creatures from Star Trek, but honestly, reality could be far stranger and more wonderful. Evolution is a creative process shaped by random chance and environmental conditions. If gravity is higher, creatures might be shorter and stockier. If its star's light is redder, plants might evolve to be black or dark purple to absorb more energy. Imagine a world with two moons, complex tides, creatures adapted to rapidly changing coastlines. On a planet with a thicker atmosphere, giant insect-like or jellyfish-like creatures might take to the skies. Perhaps intelligence stayed in the oceans, squid-like creatures communicating with bioluminescence. We shouldn't expect life to look like us. The beauty of biology is its diversity. Could life be silicon-based? Methane-based? The discovery would force broader thinking about what it means to be alive. As we search, keep an open mind. We are looking for biosignatures, chemical hints of life. The first sign might not be a radio signal or a spaceship. It might be a strange mix of gases or a subtle spectral blip, a whisper across the void, a clue telling us the universe is not sterile but brimming with creative potential. The search for another Earth is not just about looking out, it's also about looking back at ourselves. By studying the runaway greenhouse effect on Venus, we learn valuable lessons about the fragility of our own climate. By studying Mars's thin, cold air, we appreciate the preciousness of our own protective atmosphere. These other worlds are like failed Earths, each telling a cautionary tale about how things can go wrong. They provide context for just how special our own planet is. This cosmic mirror forces us to confront our responsibilities as stewards of this planet. It inspires environmental consciousness. When we see pictures of Earth from space, we are reminded of its isolation and fragility. There is no planet B within easy reach. Finding another Earth trillions of miles away only reinforces this truth. The search for other worlds makes us appreciate our own world more deeply, and compels us to protect it. We are living in an extraordinary moment. The search for Earth's twin is no longer a fringe science, it is happening right now. Every day TESS, Webb, and other instruments are scanning the stars and sending data back to Earth. The answer could come tomorrow, next year, or in the next decade. Even more powerful telescopes are on the drawing board, designed to detect atmospheres and map exoplanet surfaces. Imagine seeing continents, oceans, and weather patterns on a distant world, mapping another planet from light years away. We're moving from detecting worlds to truly exploring them, even remotely. I invite you to join us on this journey. Stay curious. Look up at the night sky and wonder what's out there. Share your thoughts. A desert world, a water world, a twin Earth? Comment below and keep the conversation going. The universe is the greatest story ever told. It's unfolding right before our eyes. If you enjoyed this voyage, subscribe for more space stories. Like and share to spread the wonder.